You're talking about the smart NICs and DPUs. VMware does that as well with offloading of NSX traffic to DPUs if you want to do that. And then they're basically offloading NSX routing and switching and firewalling to the ARM CPU that's on the smart NIC. It's actually running vSphere or ESXi on the ARM chip just to have the kernel models for doing network routing, right?
Wow. The Inception comment was brilliant, Christian. That was great.
So
ESX,
so
dreaming of ESX. Top 5 of August 2024. This is the top 5 cards for AI. Nvidia A100 at number 1, the Nvidia RTX 6000 at number 2, the RTX 4090 at number 3, the RTX A40 at number 4, and the Nvidia V100 at number 5. It's not so much about VMware. You could go and just bin VMware and put another hypervisor in. It's the way that it connects into the rest of your infrastructure that is what means that most people probably aren't going to do that, but they could, but it's going to be harder. Hello again, and welcome to this podcast. This week, again, we are joined by Charles Morale. Thank you, Charles. Welcome. And today, we talked about storage for AI last week. And today, or for teaching AI, I should say, for machine learning and AI. And this week, we're talking about the other main angle of that, which is which GPU for AI, or more importantly, is Nvidia the only game in town? What do you think? I mean, my guess is yes on this one, Charles. But what do you think?
It is more or less yes.
And it's a short episode, then.
Yeah, that's right. That's great. Thanks very much for coming.
Obviously, there's a little more material than that. But if memory serves me correctly, and if you go back to the history, Nvidia is still very much a known brand in the gaming community. If you into stuff like high-end graphics gaming and stuff like that, you have very often an Nvidia card in your PC. The Nvidia makes the smaller versions for your laptops, and I believe they're also in console games like the Xbox and PlayStation. And they've been successful for many, many years.
They have. Hands up, who's got an Nvidia GPU? Anybody? Yeah, I've got two. I've got one in this laptop, and I've got one upstairs on my computer. I've got a PlayStation 5 as well, but I don't think they use Nvidia. Just for information, but I'm not.
Maybe not. I'm not really into consoles really, and so. They came up with compute chips, specialized chips, to be able to render. Like if you play a game and you move around, and all these pixels have to be rendered to create a believable immersive environment. So it's called ray tracing. So each have to mimic how a real picture or our movie would look like in a computer game, and these are a very specific type of calculations. There's a lot of parallel calculations going on at the same time because you have to render each pixel in parallel, so you can present the complete picture. You cannot draw the picture line by line in sequence. Everything has to happen in parallel. Each computation is somewhat simple, but there's a lot of them, and they have to happen at the same time. That's the challenge in computer graphics and gaming. What happened was that in AI and machine learning, something similar is happening. If we take the classical example, the textbook example, we have a lot of pictures of cats and a lot of pictures of dogs, and each individual calculation or determination is fairly simple, but we have to do a lot of them. And scientists or developers, more or less by chance, stumbled upon that if we code our applications in a particular way and use a GPU, a graphical processing unit, that is a GPU, for gaming and maybe even professional stuff like a designer, engineer, an architect, and user, twist and turn, CAD CAM and turn around. So there is a professional aspect of it as well, but it's still images in 3D. They came up that for a particular type of AI and machine learning operations, a GPU is hugely much more powerful than the traditional CPU that you have in your computer or on the server. It's not 10 times, it's thousands and tens of thousands of times more powerful.
Well, that's the bizarre thing, isn't it? Is the fact that in reality, and I don't think they didn't really design. Well, I suppose they did design them like this. They're maths coprocessors, or what used to be called a maths coprocessor. So essentially, a GPU is not just one maths coprocessor, but hundreds of maths coprocessors almost bound together to do nothing else other than pure math
like
operations.
That. Yeah, they do a lot of parallel math operations, which are used in computer graphics, and it so happens very advantageous and advantageous in machine learning applications. So what happened was that people started using the GPUs to do experiments, because now they have practical access to compute power. Maybe state actors could rent a massive complex or build a massive complex with millions and millions of computers, but no one could really afford that if you weren't like the NSA or something like that. But what happened was that now the compute power now became a realistic, achievable resource for a lot of people, and that has really, really taken off. So I wouldn't say Nvidia invented it, but they obviously came up with something, maybe more or less by chance, to use in data science and machine learning, and that has obviously taken off.
It's a bit weird, but the other thing to bear in mind, though, if this is all about gaming hardware, Nvidia were not the only game in town when it came to gaming hardware. So it's strange that they've stolen the march, but look at this.
They sort of came up with a specific chip design that really beat the competition at some point in time.
Top 5 of August 2024. This is the top 5 cards for AI. Nvidia A100 at number 1. The Nvidia RTX 6000 at number 2, the RTX 4090 at number 3, the RTX A40 at number 4, and the Nvidia V100 at number 5. They're all Nvidia cards, the top 5. So they've completely cornered the market.
Yeah, if you would have taken that statistic like 6, 7, maybe 5 years ago and replaced AI with Bitcoin mining, then you would have had the same list. So
I didn't know that.
Basically, that's the same thing. They went from being very successful in gaming to being used for mining dollar cryptocurrency of your choice, to then being transferred over to that AI usage. It's really impressive.
Yeah, it's amazing.
I just remember that I used to have some Voodoo 3D FX cards when I played Unreal back in the day. So
that's also a long time ago. I don't know that name.
You don't remember that name, Christian? No, of course not. No, why would you?
It was on my Elsa Eraser 2 Pro that I bought at that time.
Did you play the Quake version of 3D Quake, and then they did a version of Tomb Raider as well, which was fantastic. I remember that.
Yeah, those were the days. Those were the days. I can't really play a modern like first-person shooter anymore. It's too much going on at the same time. There's too many controls. I remember Doom, it's forwards, backwards, sidestep, shoot. Then that's about it. That was simple gaming for me.
Things have changed a fraction since then. Yes,
these days. Like that.
Yeah. It's too complex these days, so that's why we're doing AI instead.
Yeah, so let the machine play the games.
Well, no, these days that with exactly the same chips, and okay, we're slightly digressing here, but exactly the same chips, part of the RTX suite of enhancements that they have to their graphics cards, they will render frames in between frames using AI to predict what happens to the pixels. So essentially, rather than getting 40 frames a second for a particular scene at 4K, you'll get 80 frames a second because it renders another frame in between each frame. So essentially it guesses what the next frame is going to be and is fast enough to generate that and present it to the screen in an area where you can't even see it. It's so fast.
Yeah, it's quite amazing.
It is amazing. It is amazing. They're using AI within their own cards. But yes, we digress.
What I suppose comes up to the topic. So Nvidia has obviously maybe not invented, but they come up with designs that really beat the competition in gaming, and they go on and on and on. And now they data center infrastructure, data center chips that's the largest part of Nvidia revenue. Gaming is still large, but data center revenue is larger. That is the single largest revenue stream.
And they've not just, they didn't stop there, did they? They stopped. They created this in the original chips with CUDA cores or whatever other components they call within them, and they've done different iterations of that where they're following Moore's law and they're getting bigger and they're getting faster and they're putting more in. But then they went and they created a network card to provide the throughput to feed that. Is that right?
Nvidia bought a company called Mellanox a few years ago. I can't remember exactly when. So the network cards that Mellanox had, the brand is still there. If you want to build a server, I can go into the menus and I can connect a Nvidia Mellanox card. So the brand is still there. The Mellanox switches are still around for Ethernet, but also InfiniBand. Which is still used today in high-performance computing. It doesn't have to be strictly AI and machine learning. Classic, if you will, high-performance computing with a lot of CPU power is still very much a thing. But that's been a thing for many years, but that's their own little niche there. But InfiniBand is still very much in use. And if we go back into NVIDIA, they take the networking products from the Mellanox brand, and they put it into their machines, the NVIDIA DGX systems with the NVIDIA GPU cards, and then the Mellanox networking InfiniBand or in the Ethernet cards. They can actually be set to either InfiniBand mode or Ethernet mode, depending on your preference.
Wow. Okay.
So they are also DPUs, so they actually have ARM CPUs on them that can also
augment because
the offloading.
Now we're in a Formula One race. We really need to squeeze every single little bit of performance out of. So yes, smart NICs or DPUs, if you will, to actually redirect network traffic so it doesn't go through the CPUs. It goes straight to the GPUs over the network into the GPU in another DGX node across in often many cases the InfiniBand network for the absolute top performance. It doesn't, well, of course costs matter, but we really want to invest in specialized networking equipment to really squeeze that single little last bit of performance out of this business system.
So essentially they're approaching the marketing of this AI type infrastructure with the marketing they did with their GPUs, which was almost like every year there'd be the next card, and the next card would be 20% faster at this thing, 30% faster at this thing, 40% faster than the opposition. And they would obviously maybe massage the test to make it look like their card was the best, but it would be a constant arms race to get the most frames per second. And they're doing exactly the same thing now with regard to the way that they generate AI hardware.
Yeah, and NVIDIA has, I don't know, I'm not entirely sure if it's available for purchase today. But it has. There is an ARM CPU made by NVIDIA, and an ARM CPU is there's a company or a company that owns the design, but that company does not actually make the chips. So NVIDIA bought a license to make their ARM CPU. And what they've done is to take the ARM CPU, the Grace architecture, and marry it to the GPU architecture called Hopper. And now we have a Grace Hopper card, like a physical card in the server, which is a ARM CPU and an Hopper GPU, and they sort of glued them. Well, they are still different chips, but they the bandwidth between them is absolutely massive because they can keep it on the ball, and
it's an interconnect on the chip
on
the board itself
between chips. Now we're really stepping up into the Formula One racing game for this really large machines.
Okay, hold on. We've now done so. Nvidia, yeah, good. No surprise that they're currently the best. But the whole point is, are they the only game in town? What other options are there other than Nvidia? Because let's face it, at the moment, buying an Nvidia CPU, GPU, whatever it turns out to be, tough to do. They're a bit, costly and rare.
I get the question quite a lot. I have to admire Nvidia. They run a successful business, obviously, but competition is always good.
And required,
and required to keep everyone on their toes. Intel has been working with their GPUs.
Because I never even heard that Intel did AI GPUs.
They forayed into a bit of in a little bit in game GPUs. I think they call ARC. I'm not really the ARC GPUs in the gaming segment, but their data center GPUs are called Gaudi.
Oh right,
and they are announced, and I've been looking into, for example, one of our server suppliers, Dell, and they have now. It's now possible to actually at least get a quote with Gaudi 3 GPUs in a Dell server. It doesn't appear like Intel doesn't look like they will release their own complete server, like Nvidia does with the GTX systems, which incidentally runs Intel CPUs. In the GTX H100, the previous A100 ran in AMD CPUs, but the H100 does Intel. And so, I said, Intel is now, so the Gaudi 3 GPU from Intel is available to actually see in the spec sheets. I think they will be ready for delivery quite soon, if not today.
When you are looking for your projects, what to use and what to recommend, are you looking for specific parameters like I think it's called TOPS, right? The kind of speed that you can do with the GPU or an NPU or whatever.
That is absolutely correct. It's called TOPS or TFLOPS, actually teraflops, billion floating point operations per second, which is a mathematical term, and then it gets to be further refined what's the precision of the floating point operation. I can talk a little bit about that as an example. So there was a request from a university in Sweden, where they in the request they are running Nvidia GPUs, but it was very formal request for quote or request for proposal. We need 150 teraflops in 32-bit precision, and we need a bit of memory because there's a lot of memory in these GPU chips, because the computational model has to fit in the memory to effectively to do the calculations, and there are a few other parameters like bandwidth between GPUs. So I did the math, and I used I used some at the time Nvidia GPUs, because they actually had Nvidia specific requirements as well. They didn't write them out, but it was quite obvious only Nvidia would be able to answer this. Teraflops can be a parameter in procurements. Absolutely. To achieve a certain amount of performance in your operation.
But what about? I mean, one of the other things that so Intel are coming out with it. Where are AMD in this situation? Because AMD they're the primary competitor for Nvidia. They have been for Nvidia's entire life,
and they are also available today. I saw
right, cool.
so the let's see if I get it right. NY300X is called. GPU also available in, for example, Dell servers. I haven't really looked into all the other manufacturers, but they are absolutely available now. And according to what I can see, they are available to be ordered and shipped today.
Fair enough.
That's the hardware angle, and I might also mention if we came into this little talk about from an Nvidia starting point. Nvidia has made gaming GPUs, and they also have data center GPUs in a wide variety of sizes. It's still an important use case with visualization. The designers and engineers, CAD/CAM, they still need those kind of GPUs, and those kind of GPUs are often optimized for that particular task. But calculations in machine learning it's almost always another model that is more optimal. You could probably run machine learning calculations on a display optimized card. The machine learning optimized cards, they cannot run any display. They cannot render graphics. So a graphical processing unit that cannot render graphics, but here, there we are. So Nvidia has a smaller mid-range and the largest size. We always talk about the largest GPU, the A100 and the H100 and the H200 and the B200 that is coming along. It appears to me that AMD and Intel want to compete in the high end. They want to, they don't really have, they had like gaming chip, but it doesn't appear to me they have the breadth of smaller scale GPUs.
I was going to say, because actually I thought that would be the ideal situation, because at the moment what we see is Nvidia
someone
just
correct me if I'm wrong, but that's what I've seen in the system.
No, you're probably right. But and you can imagine them wanting to go for that marketplace, because that marketplace is
they want to
where
compete
most of the business is.
On the very to compete against the 8 GPU, because that seems to be the magic number. In a single server chassis, you can fit 8 GPUs, and they are interconnected in some very high bandwidth interconnect.
Yeah.
So the memory and the GPUs can talk to each other in a server chassis.
But it's interesting looking at this from where Intel is at the moment, right? Because Intel has really struggled for a while. AMD had a resurgence a few years ago, which kind of on the CPU side, right? And Intel were kind of lagging behind in a way, and not innovating at the same frequency as they have been. And they also seem to be a bit late to the party here on the AI things as well.
So yeah.
And at the same time, there's the whole ARM CPU kind of shift as well. I mean, my MacBook is an Apple, but it's basically an ARM CPU, right? There are more competition for Intel now than there's basically ever been, and they need to, and your mobile phones as well. So they kind of need to pivot in a way, because they have some issues on hand that they need to address, and probably pretty quickly as well.
That is true. Actually, Intel is not doing so well. So I'm not sure whether this still will take off, but they are actually they are releasing GPUs, and I could touch a little bit on the subject on ARM CPUs, and when ARM CPUs, if they get mainstream, if and when they get mainstream, and I was in a little talk, or at least I heard someone give a talk about this specifically. Can we use ARM CPUs instead of Intel or x86 compatible CPUs? Well, if you own the source code, you could then, in theory, compile it to ARM CPU.
Absolutely.
So you could absolutely not take your running applications and binaries running on Intel or x86 into ARM. But you have to recompile it. Yeah. And the message is, yes, you can just recompile it, but to really optimize it around it, you need to do a lot of work. Is it worth it? If you're on Formula One, really want to, again, squeeze that extra last bit of performance, it might be worth the effort. or it might not. I don't know where this will take off on the CPU.
No, but there's again, VMware is running ESXi on ARM now, so you can virtualize. You can run ESXi on a Raspberry Pi if you want to. It doesn't make any sense to do so, but you can do it.
Gotta say, well, that's an interesting project.
Yeah, there aren't room for many VMs. Let's put it that way. And also, we're talking about the smart NICs and DPUs. VMware does that as well with offloading of NSX traffic to DPUs if you want to do that. And then they're basically offloading NSX routing and switching and firewalling to the ARM CPU that's on the smart NIC. That ARM CPU on the smart NIC is actually running vSphere or ESXi on the ARM chip just to have the kernel models for doing network routing, right? So inside a server where you have an x86 CPU, you have a network card with an ARM CPU that runs a hypervisor.
Wow, the Inception comment was brilliant, Christian. That was great. So ESX, dreaming of ESX.
There is a real kind of shift towards the ARM infrastructure as well. You might not be able to run anything, but everything. I mean, but you can get Windows for ARM these days.
Absolutely.
You can get Linux. You get your MacBooks. And it works.
The key point here is why is it important? And why it's important is the fact that ARM tends to be far more power friendly than Intel does. So if you imagine you're running a massive AI learning environment, and imagine the amount of power that is consuming, you could save yourself millions of pounds a year if you switched it to an ARM CPU.
Yeah, I saw the announcement and specifications for the Nvidia's machine based on the B200 chips, but they actually want to not only sell you this 6 or 10 unit server chassis box, they want to sell you a full rack of machines with GPUs and processing power. So you buy the full rack. That's the building block.
Yeah.
It draw 100 kilowatts. Ooh. And to put that in perspective, a full rack draws 100 kilowatts. There are service providers, co-location providers, that will cap your rack below 10 kilowatts. If you want more power, you have to rent more racks that will then have 32 racks sitting empty because you need to feed one rack with the power that is allocated for 3 or 4 racks. Wow. And another customer I talked to, 100 kilowatts. That's what we run into our entire data center.
Yeah.
The power and cooling is there. On that, if I take a little detour, or not a detour, but another way, we talked about the chips and ARM CPUs and the power consumption, but let's not forget maybe the even more important part is all the software. Nvidia has really, over the years, built up a huge ecosystem with software development kits and drivers and frameworks. They really want to make it easy to in your science. You do robotics, you do pharmaceuticals, you do traffic planning. They have like software frameworks for many different disciplines. And again, they are very successful.
I'm going to throw some buzzwords. TensorRT, TensorFlow, Triton Interface, PyTorch, Rapids. Yes. I mean, there's loads of them that they've generated software, or they've combined with companies to create software just to do this job.
So moving to, is there another game in town? Yes, we talked about AMD and Intel. Will the move happen? How will that actually work out? And I'm picking up when I go around and I need to listen to scientists and developers. Yeah, Nvidia is they're too dominant. They have the monopoly and the CUDA libraries. Oh, but we can work around that because there are now more open frameworks available. So we aren't really locked into Nvidia, or we are locked. I'm not sure what will happen in practical terms. But it's not only the chips. It's not only the hardware.
Exactly. That's it, right? It's not only being able to manufacture a chip and put it on a breadboard and ship it out there. It needs to be accessible and usable, right? And if everyone is used to using NVIDIA's way of doing things, it's going to be really hard to shift that over to do something else. And basically, the only way of doing that is for other manufacturers to kind of emulate the same APIs or the same connection points, so that the existing systems that interact with NVIDIA can just be ported over, pointed to the Intel chip instead, and it works. If that happens, then you will actually have a competition on your hands, right? So I did some background here on the Intel thing, and they are saying that we support PyTorch, we support these things, and that's kind of the thing. They have to do that. If not, it's just going to be hardware that settles or gathers dust and does nothing else, because you won't shift it out for something completely different. You won't start again.
This reminds me very much of a conversation we had about a certain hypervisor company that changed their licensing model recently. Mentioning no names.
Exactly the same thing.
Yeah, that sort of stuff. But the point there is the fact that, one of the things that we said on that podcast was the fact that it's not so much about VMware. You could go and just bin VMware and put another hypervisor in, and you could buy an open source one to do the same job. It's the way that it connects into the rest of your infrastructure that is what means that most people probably aren't going to do that. But they could, but it's going to make it harder.
It's the ecosystem around it. It's the management of it that in totality with the hardware actually provides the service that the data scientists need. And if you only have one of the components, they won't use it. It's pretty simple.
So time will tell. I am currently participating in a project here in Sweden. It's called the Next Generation Infrastructure for AI, and it's no big secret that Intel is part of that project as well. And I'm excited to see how this will all turn out over the following years. But there is absolutely competition for NVIDIA, which is good. But how well, as Christian, you talked about, how well will that fit in? Can we? It is not as easy as drop in another chip manufacturer. There's a lot more going on, and if the adoption will there, I don't know. Okay, going back to NVIDIA, on that topic, since it is the de facto standard today. I was attending a talk from a PhD. He's involved in natural language understanding and natural language processing, and they are oriented around how many A100 days do we need. A100 is the previous, like the high end GPU chip from Nvidia.
Yeah, the current number one in Nvidia.
To run this experiment, we need 7 A100 days. They have aligned their entire research. How many days does this experiment need when we run it? Because it is the de facto only available option for them.
Yeah, it's the same thing. It's the same thing as people talking about I have to Google something, right? Yeah. The synonym between Google and actually doing an internet search.
Yeah.
And this is the equivalent in the kind of GPU space, right? How many of this particular thing do we need? It's not the kind of result. It's just a synonym between a product and the service you get.
It's the same thing, because they grown up on this. This was the only available resource, and in practical terms, is the only available resource. So obviously they align around that.
I don't know about you guys, but I think we're getting close to the end of this podcast, because I need to go and do some hoovering.
Right.
Obviously, that's again a product that became ubiquitous with its name, even though it wasn't called it was a product name rather than actually a thing.
I believe cling film is a brand. It's not.
There you go.
Yeah.
There are some, aren't there, that always sort of win. But there you go. I'm going to say VHS. That's probably another one.
Yeah.
Betamax failed.
Yeah, but we're still talking about actually taping stuff when we film it with a digital phone.
Yeah, there's no magnetic tape going there.
Yeah. I haven't found the tape in my phone yet, so.
Thanks for that, Charles. I think the key point here at the moment is this is a really interesting subject. I still get the impression we're still at the infancy of this sort of stuff, though. This is moving so quickly.
Yeah. See how this turns out over the next few years.
It'd be interesting to see how these other manufacturers come into it to bring the fight to Nvidia, because at the end of the day, certainly at the moment, it looks like they've really sort of got it by the horns. Very much appreciate your insight. Thank you very much, Christian and Christian. It's lovely to see you again, and we'll see you all at the next one.